Okay, we're moving on to section 7.4. What we're basically doing in this section is we're taking the properties and the definitions of the quadrilaterals from the previous section, and we're applying those properties to various types of problems, whether it's an algebraic problem or a proof. So let's go ahead and jump right in, and let's try some problems, and I think you'll get a sense of what we're looking at here. Okay, so for the first problem here, we're looking at a rhombus, so we got to think about the various properties of a rhombus. And it says that angle MOB is 9x plus 11. So that's this angle right here. And MRH is 76. Now we know that for a rhombus, we know that the opposite angles of a rhombus are congruent to each other. So we know that this is also 76. Okay, so opposite angles congruent. We also know that the diagonals bisect the angles in a rhombus. So I know that if this is 76, then I know that 2 times 9x plus 11 has to be equal to 76. Okay, and so if I solve this thing for x, I can divide both sides by 2, and then solve for x. X ends up being equal to positive 3. And what we're looking for here is we're looking for OH, which is the side of a rhombus. So we're looking for this side right here. And we know that all 4 sides are the same. So if I can find RH, then I know that I found OH. Okay, and so RH I find by plugging in 3 right there. I get 31 for RH, but I know that OH and RH are exactly the same, so side length OH has got to be equal to 31. All right, got a proof here, so let's try this one. Given that this is an isosceles trapezoid, so I know that this side is parallel to this side. I know that this is congruent to this also, because it's an isosceles trapezoid. Those are all properties of an isosceles trapezoid. And you want to prove that YTX and angle W, you want to prove that these two are congruent to each other. Okay, so looks to me like these two are congruent to each other because they're upper base angles of an isosceles trapezoid. You also know that these are congruent to each other because they are alternate interior angles. And so by transitive property, you should be able to say that these two are equal to each other. So let's go ahead and write this out. So I know I got a bunch of givens here. Please don't do that on an actual test or quiz, but for now I'm going to do that for the sake of time. I know that XW is parallel to TV. That's because in a trapezoid, there's one pair of opposite sides parallel. And because of that, I know that angle X is congruent to angle XTY. Because if I have parallel lines, then the alternate interior angles are congruent. And then next, I can say that angle X is congruent to angle W. And that's going to be because of one of the properties. Because in an isosceles trapezoid, if you have an isosceles trapezoid, then the upper base angles are congruent. And now I can go ahead and finish it by saying that this is true down here in step 5, and that of course would just be a transitive property. Okay, so that's what a proof will look like. let's jump down and do one more algebraic before we hit some more on the back side. Care is a square, haha. So CS is 3x plus 10. AS is 4y plus 7. And angle CSA, this angle that we know is a right angle down here, is going to be 7x plus 13. So I can go ahead and right away I know that I can say that 7x plus 13 has got to be equal to 90. Solve for x. X is going to be equal to 11 when I do the algebra. I can plug that 11 in for this right there. That's going to give me the length of CS, which CS will end up being 43. And now to find y, I know that in a square, one of the properties is that the diagonals are congruent and they bisect each other. So because of that, I know that CS and AS have to be the same. And so now I can say that 4y plus 7, which is AS, has got to be equal to 43, and I can solve for y. So y is going to be equal to 9. Okay, on this second page here, let's go ahead and let's try this first proof here, number 4. It says that HEAD is a parallelogram. That's supposed to be a parallelogram symbol there. Sorry about that. And CE is congruent to RD. And from that, hopefully you can see that if this is congruent to this, then they're overlapping, which means, hopefully, from our experience, that by subtraction, you can get that this is congruent to this. And we have a bunch of properties here that we can work with. And we're trying to find that this thing is congruent to this thing. And hopefully you can see from some of the action here, like for example, I know that because of the properties, I know that this side has got to be congruent to this side because the opposite sides of a parallelogram are congruent. And so hopefully you can see from all the action going on there that I think we're looking at trying to prove that these two triangles are congruent to each other. And perhaps you can see also that because you have parallel lines here, that these angles are alternate interior angles, and so the triangles are congruent to each other. So let's go ahead and try writing this proof out, and hopefully you'll follow along. So the first thing here is the givens. Write those out, please. I know that DC is congruent to RE by subtraction. I also know that HD was congruent to EA. And here's where we have to use the properties. So if it's a parallelogram, then opposite sides are congruent. We can do the same thing here with the opposite sides being parallel. So it's a separate step here. I can use that symbol. I can also use just the word parallelogram or p-gram. Opposite sides are parallel. Now I can go ahead and do the alternate interior angles. Let's highlight this a little bit better here so that you can kind of see it. But the alternate interior angles are going to be right here. So you have those right there. So that means that angle HER, angle HDC, sorry, HDC is congruent to angle AER. Because if you have parallel lines, then the alternate interior angles are congruent. And now I can say that the triangles are congruent to each other. So triangle HDC is congruent to triangle AER by side, angle side. So it's going to be 2, 3, and 5. And now I can just do a CP-CTC at the end of that for step 7, and I am done. CP-CTC. Okay, let's skip to the last page here and just grab a couple of other quick problems. Okay, on to the last page here. Let's try problem number 7 here. It says that trap is an isosceles trapezoid, which means that angle T is 12x minus 12, that's given, and R is 8x plus 26. We know that these two angles, because it's an isosceles trapezoid and the upper base angles of an isosceles trapezoid are congruent to each other, we can set those equal to each other. So I know that 12x minus 12 has got to be equal to 8x plus 26. I can solve for x. X ends up being 9.5, and then I can just plug it back in to find the values for T and R. Okay, and then the last problem I want to look at is this one here. It's pretty common, but it's actually a lot easier than it looks. Okay, you got a parallelogram here, which means that these are parallel to each other, and so they have the same slope, which means that if I want to find this point right here, B, all I need to do is go from the D, go the same amount to the left, and then the same amount up, and do the exact same thing for going from the A to the B. So go to the same amount to the left, and then the same amount up to get to where the B is. And I believe if you do that, you will get 6, 8. And you can just count. It's not a problem to do that. And on any of these type of problems where you have to find that 4th point, that's all you will need to do. Okay, I'm going to stop here and give you an opportunity to try some problems. Okay, good luck. Take care.